All right, my algebra class, let's go ahead and knock this out. We got problems 1 through 6, 9 through 12, 19 through 22, 27 through 30, and 35 through 36. It says in exercise 1 through 8, find the degree of the monomials. We see here that there's only one variable to the, well, it doesn't have anything. That means it's to the first power. So this is going to be the degree to the first power. All right, the degree of the binomial is 1. Over here we have no variable. You might think it'd be 1, but remember, this is going to be really like times, over here it's times whatever this number is. Since there's nothing here, it's like times 1. And since it's times 1, we know that we need a 0 by the variable because anything to the 0 power is 1. So this degree of the monomial is going to be 0. Over here we see k is to the second powers. There's no other variables, so it's going to be to the second power. Right? Degree is 2. Then this degree is going to be to 4. Again, there's no other variables here. We have 2 variables here. We have 8 on one and then 1 on the other. 8 plus 1 is 9. So the degree of the monomial will be 9. Over here we have 2 variables. 2 and 4 are the exponents, so 2 plus 4 will be 6. The degree of the monomial is 6. All right, let's move on. Let's go through 9 through 12 now. So write a polynomial in standard form. Identify the degree and leading coefficient of the polynomial and classify the polynomial by the numbers of degrees. Wow, okay. So write the polynomial in standard form. There's no other things added onto this, so it would still be 3t to the 8th power. So as identify the degree, that's going to be the degree is 8. The leading coefficient would be 3, and this is a monomial, it's by itself. So the polynomial is in standard form already. It's to the 8th degree. It says the coefficient is 3, like I said, what was in front. And the polynomial has 1 term, so it's a monomial. Over here, once again, we have a monomial. There's only 1 variable here. The degree is to the 4th power. But then remember we have this, we've got the square root of 7 over here. Let me make some room for this answer. So identifying the degree should be 4 leading coefficients. Since there's no square root of 7, I would think it's still going to be the square root of 7. If the calculator gives you an answer, I guess you could write that. And classify it, we're still looking at, I believe, a monomial. So we have over here, it is in standard form. The only term has a degree of 4, so it's to the 4th degree. The leading coefficient is square root of 7, so like I said, has 1 term, so it's a monomial. Here, the standard form would be the degree is the highest powers up front, so we would put 3p to the second power plus 7. That would be writing it in standard form. Then the degree, there's only 1 variable here, so it's going to be second power. Leading coefficient will be 3, since 3 will be in front. This is a binomial, since there's 2 of them. So the greatest degree, again, is 2, so the degree of the polynomial is 2. Standard form was 3p to the second power plus 7, like I said. The leading coefficient was 3, and then the terms is 2 of them, so it's a binomial. Once again, we're looking at a binomial here with 2 terms. The 12th degree is bigger than 11, so we would put negative w to the 12th power plus 4w to the 11th for the standard form. Let's see, they're asking for degrees. We're going to have to add these 2 together, right? So let's see, as a, in standard form, the negative w to the 12th power comes in front of positive 4w to the 11th, right? So the greatest degree is 12. So the degree of the polynomial is 12. The leading coefficient is -1, since we know there's a 1 there. The polynomial has 2 terms, so there's a binomial, all right? And I stand corrected as far as saying to add these. I forgot this isn't multiplication where you would go and add these together. So we just go by the leading, so I apologize for that. Let's go on to 19 through 22, find the sum. Well, let's see if we're adding these together. I got 5y minus 2y, that's 3y. And 4 plus 6, so it's going to be 3y plus 10. All right, And they used putting them side by side. They grouped the exponents together, right? The like terms. Let's go with number 20 now. 20, we see we have negative 8x minus 12 plus 9x plus 4. We know that 9x minus 8x is just x, and negative 12 plus 4 will give us negative 8. So that's going to be 8, or x minus 8. X minus 8. All right, again, they went side by side with this. If I was them, I probably would stack them, went vertically, and put, like over here, I put negative n underneath here, negative 3n over here, and positive 11 over here. That would give me n to the second power minus n to the second power. That's going to be 2 minus 1. So that would be n to the second power minus 8n plus 5. N to the second power minus 8n plus 5. And again, they group these by like terms. Over here, if adding again, so we're 3p to the third power minus p to the third power gives us negative 4p to the third power. Then we have 5p to the second power minus 8p to the second power. That's going to give us negative 3p to the second power. And we have negative 2p minus 7, or 15p, which will give us negative 17p. So you see negative 4p to the third power, right? We added these two together since they're both negative. We're subtracting these. 8 minus 5 will give us negative 3p to the second power, right? This is the alternate solution by stacking them. Right? We took the negative p to the third power, put it under here. Both of them are negative, so we're going to add them together. We took the negative 8p to the second power here. Our signs are different, so we find the difference. 8 minus 5 is 3. Keep the sign of the bigger number. Both of these are negative, right? So 15 and 2 make 17, negative 17p. All right, let's move on. Now it says find the difference. This time we have a subtraction sign in between, which means all these signs are going to be the opposite. So this would be a negative 3d. Negative 3d plus d will give us a negative 2d. And negative 9 plus 1 will give us 8, or negative 8, excuse me. So we should have negative 2d minus 8. Over here we see that we've got, well, if this is a negative 7 plus 6 will give us negative x. And if this is a negative 1, 9 minus 1 will give us 8. So this should be negative x plus 8. Over here we'll take the negative 3y to the second power, combine it with the y to the second power. That's going to give us negative 2y to the second power. We're going to take this negative times the negative. That's going to be a positive 6y. Combined with the negative 4y will give us a positive 2y. And then 9y, this is also going to be a positive 9. I'm sorry, not y, 9 plus 9 to give us 18. So this will give us negative 2y to the second power plus 2y plus 18. And then over here, sorry, I thought it would give us an alternative method. We got 4m to the second power. This is going to give us a negative times a negative, which is positive. That's going to give us a positive 3m to the second power. So that's going to be 7m to the second power. This is going to be a negative 10. Combined with this negative m, will give us negative 11m. And this will give us a negative 4 plus 2 will give us a negative 2. So 7m to the second power minus 11m minus 2. Alternate solution would have been putting all that underneath. You see that we have negative, so all these which turn them the opposite, positive, negative 10m, and negative 4. This is what we talked about up here. So 4 plus 3 is 7. Negative and negative means we're going to add these, which mean 1 plus 10 is 11. And then different signs, 4 minus 2 will give us 2. Keep the sign of the bigger number. All right, 35 and 36 are our last one. Just says describe and correct the error in finding the sum or difference. This is a negative sign, so all these will be the opposite. So this would be a negative 2, negative 2x to the second power, plus x to the second power give us negative x to the second power. This part is correct. Then we have negative times a negative. This is going to give us a positive. So this would be 3x 3x plus 3x will give us 4x, and that's the problem there. They went ahead and kept this as a negative 3x, combine it with this to make a negative 2. So it should be negative x to the second power plus 4x, and that's what it is, negative x to the second power plus 4x. Okay, the problem was when writing or subtracting as addition, the last term of the polynomial was not multiplied by negative 1. That was not multiplied to this. Negative times a negative is a positive. All right, next, they got x to the third power minus 4 to x to the second power plus 3. We're lining up negative 3. This is a plus, so we're going to keep all these signs. Our signs are different, so we find the difference. This would be 3 minus 1, which would give us 2. Keep the sign of the bigger one. So this is correct, negative 2x to the third power. Then over here, we have two different signs again. 8 minus 4 will give us 4, and the bigger number is positive, so it'll be a positive 4x to the second power. But here's the problem. This is not to the second power, is it? So these two should not have been combined at all. All right, this should have remained negative 4x to the second power. This should have remained plus 8x, because there's not a power of 2 or a power of 1 to combine with these. These are not like terms. And then 3 minus 2 is 1. So the only thing wrong is this should have been negative 2x to the third power minus 4x to the second power plus 8x plus 1. And just like I said here, these two shouldn't have been combined. Negative 2x to the third power minus 4x to the second power plus x plus 1. And I believe that was all the homework. You have the rest to do, so I'll see you in class for grading. Have a great night.